Today, let's learn how to draw the sand grading curve. You can judge whether the gradation of sand is qualified or not in just 3 steps. To judge whether the gradation of sand is qualified or not, we can compare the accumulated retained percentage after sand screening with the gradation interval values in the gradation table of standards 1 by 1, as shown in the following table. Compare the values in the third column with those in the second column 1 by 1, and all the values in the third column are within the numerical interval of the second column, so it can be concluded that the gradation of the sand sample is qualified. However, the conclusion that whether the gradation is qualified or not won't be obtained until the 6 values are compared. This method is not visualized enough and is inconvenient for expression in the test report. So, is there a better way? Yes, we can use the grading curve to express the qualification of sand gradation more visually. What is a grading curve? The grading curve is a curve showing the proportion of aggregates with different particle sizes. Next, taking natural sand as an example, we can draw the sand grading curve and judge the sand gradation in only 3 steps. The first step is to establish a grid coordinate system. Draw the grid coordinate system with the mesh size as the abscissa and the accumulated retained percentage of sand after sieving as the ordinate. The abscissas in the coordinate system are screen bottom, 0.15 millimeters, 0.30 millimeters, 0.60 millimeters, 1.18 millimeters, 2.36 millimeters, 4.75 millimeters, and 9.5 millimeters respectively, and the ordinate is from 0 to 100%. The second step is to draw the grading range curve in the grading area. Take the natural sand in Area 2 as an example. In the gradation table of standard GB/T14584-2011 Sand for Construction, the accumulated retained percentage of each mesh size is a numerical range. The larger value is called the upper limit of this range, and the smaller value is called the lower limit, as shown in the following table. According to the table, 6 coordinate points for the lower limit of the grading range and 6 coordinate points for the upper limit can be listed as follows. In the coordinate system in the first step, we find the 6 coordinate points for the lower limit. That is 4.75, 2.36, 1.18, 10, 0.60, 41, 0.30, 70, and 0.15, 90. Connect a line point by point to obtain the lower limit curve of the grading range in the grading zone, namely the blue curve in the figure, and then find 6 coordinate points: 4.75, 10, 2.36, 25, 1.18, 50, 0.60, 70, 0.30, 92, and 0.15, 100. Connect the lines point by point to obtain the upper limit curve. That is the red curve in the figure. The 2 curves constitute the grading curve of natural sand in Area 2, where the blue curve represents the lower limit and the red curve represents the upper limit. Figure 1 is the grading range curve of natural sand in Area 2. The third step is to draw the sand sample grading curve. In the grading range curve in the second step, take mesh size, accumulated retained percentage of sand sample for screening test as coordinates to point out a series of coordinate points and connect them into a curve. That is the grading curve. According to the screening test results of a sand sample in the table below, 6 coordinate points of the grading curve can be listed as follows. In the grading range curve chart in the second step, find out 6 coordinate points of the grading curve of the sand sample and connect them one by one to obtain the sieve grading curve in Figure 2. That is the green curve in the figure. According to Figure 2, the gradation can be visually judged. When the sand sample grading curve is within the grading range curve, the gradation is qualified. The sand sample grading curve in actual production practice may also have the following conditions. As shown in the sand sample grading curve in Figure 3, the accumulated residue on the 4.75 mm meshes has exceeded the range, and the gradation can be directly judged. When the coordinate point corresponding to the meshes of the grading curve, that is, yellow line 4.75 mm in the figure of sand sample is not within the grading range curve, that is, red and blue lines in the figure, the gradation is unqualified. As shown in the sand sample grading curve, the accumulated residue on the 0.60 mm meshes has exceeded the range of Area 1. The gradation can be judged according to this figure. When the coordinate point corresponding to 0.60 mm meshes on the sand sample grading curve, that is, brown line, is not within the grading range curve of Area 1, red and blue lines, the gradation is unqualified. As shown in the sand sample grading curve in Figure 5, the accumulated residue on the 0.60 mm meshes has exceeded the grading range curve in Area 3. The gradation can be judged according to this figure. When the coordinate point corresponding to 0.60 mm meshes is not within the grading range curve of Area 3, the gradation is unqualified. As shown in the sand sample grading curve in Figure 6, the accumulated residue on the 1.18 mm, 0.30 mm, and 0.15 mm sieves exceeds 1%, 0.8%, and 2% respectively, exceeding 3.8% in total. The gradation can be judged according to this figure, except that the coordinate points corresponding to 4.75 mm and 0.6 mm meshes are all within the curve of gradation interval. The accumulated residue on other meshes can exceed the limit, but the exceeding shall not be more than 5%. If it exceeds 5%, the gradation is unqualified. Now, let's review the process of drawing the grading curve. The first step is to establish a grid coordinate system with the mesh size as the abscissa and the accumulated retained percentage of sand as the ordinate. The second step is to draw the upper and lower limit coordinate points of the gradation range in the middle point of the grid coordinate system and connect them to form a grading range curve. The last step is to plot the coordinates and connect them to form a grading curve of sand according to the accumulated retained percentage of the test sand sample. According to the position of the sand grading curve and grading range curve, the picture book situation of sand can be directly judged. We can see that in the above drawing process, several details should be paid attention to. The two 9.5 mm abscissa of the bottom can be removed. The ordinate of the origin is 100 instead of 0. The scales of the three ordinates and abscissa are not required to be the same. The order of drawing curves in the second and third steps can be exchanged. That is to say, the standard grading interval curve can be drawn first, and then the sand sample grading curve can be drawn. The curves in the 5 figures can be represented by broken lines. That is, the coordinates of 2 points can be connected by a broken line without affecting the judgment results. What we have learned above is to take the natural sand in Area 2 as an example to introduce the drawing method of grading curve. Please think about what the difference between the drawing of grading curves of natural sand in Area 1 and 3 and that in Area 2 is. For other types of aggregates, such as manufactured sand or crushed stone, what is the difference between drawing the grading curve and that for Area 2? Okay, that's all for the drawing of sand grading curve drawing today. Thank you.